People here, please confirm. Do you know what is a population? Do you know what is a population?
You're asking the figure?
Population.
Total numbers of data points.
Okay, the total set of data. Suppose your company is producing a product and the diameter is critical to quality characteristics, right? And definitely your company is producing for several years. Producing for several years. And let's say 5 years. Now 5 years data is available with you. This 5 years data is population. All of you understand? Now the population will have an average. Am I right?
Yes.
This is statistically denoted by the symbol mu. I'm just typing using English letter mu, but mu symbol, hope all of you know, right? Mu.
Yes.
I will also show it separately. So mu. And now let us say the mu is 100 mm. Mu is 100 mm. So if mu is 100 mm and the customer requirement is also 100 mm. That means you are able to produce products meeting the customer target, customer requirement. The customer target and your population average are same. That is really a good scenario. And now for the population data, there will be population standard deviation. Am I correct?
Yes.
Yes.
This population standard deviation will be denoted by the symbol called sigma. I'll show you all the symbols also in the whiteboard. So now all of you have understood the population. Population will have average. What is the symbol for average? Population average? Mu.
Mu.
Symbol for population standard deviation?
Sigma.
So let me say the sigma is equal to 0.2 mm. What do you understand out of it? Can one of you tell me? You have produced, so many products, so many units you produced, and so much of data is available. With so much of data, you have understood two things. Population average is 100 mm. Population standard deviation is 0.2. Now, what do you understand about the population? Can somebody now summarize about population? Come on. Anybody, can you summarize the population? I want you to talk about the population. Will you be able to talk about the population? Last 5 years, your company has produced and the data is available. Mean is given to you. Standard deviation is given to you. What do you know about the quality of the products your company has produced? Any idea?
We can find out by using that sigma, sir. Sigma and mu, upper specification or lower specification, like that. Control, upper control, process limit.
Can I say like this? Can I write this statement?
Yes.
68.27% of the population are between 100 plus or minus 0.2. How am I saying this?
Yes.
$100 plus or minus 0.4.
0.4.
What is 0.4 here?
Two sigma.
Sigma. Or between 100 plus or
0.6.
minus 0.6.
0.6.
Now, What is 100 plus or minus 0.6? Upper control limit is how much? 100.6. Lower control limit is how much? Am I
Yeah.
correct?
99.4.
Now, what is USL? Let us say USL is 102. I'm very liberal. Customer is very liberal. LSL is 98. Now what do you understand? 99.73% of your population are between 99.4 and 100.6. But with respect to the specification limit, almost everything your company has produced in the last 5 years are always within the specification. Am I correct?
Yes.
Yes.
According to the theory, 99.73 is damn sure within 99.4 and 100.6. And since specifications are much outside the control limits, and the data is clearly giving me an evidence that my company is capable of meeting the customer requirement in the last 5 years. No problem, right? So now you understood about the population. You understood about the population. Now, one particular day, you are in a company, right? You have visited the shop floor. You have visited the shop floor and you collected 100 samples. You collected 100 sample units. How many units you collected? 100 sample units you collected. Now, every unit will give you a diameter value. Am I right? 100.15. Some value will come. Am I correct or not? 99.85. How many data you will get like this?
100.
Now, this data is called sample data. Earlier, it was population data, isn't it?
Yes.
It was it is rare. It is very, very difficult to have an idea about the population. Access to the population data is very rare. Most of the time, data may not be available. People will only tell some reference, isn't it? They'll say, no, we are producing 100 mm, we are producing 100 mm. But what are you producing? You will know only when the population data is available, right? Most of the time, the customer requirement or the reference values are considered the population parameters. Anything you calculate using the population data are called parameters. What are parameters? Anything you calculate using population data are called parameters. What is mu? Mu is a parameter. Am I right? Mu is a parameter. What is sigma? Sigma is another parameter. Parameter means the characteristics of the population. How your population data behaved. How your population data is behaving. I understand through certain numbers. Those numbers are called parameters. Now coming to the sample data. Can you calculate average for the sample?
Yes.
Now sample average, the symbol should be X bar. You can calculate average for sample. The symbol is X bar. Now for the sample, can you calculate standard deviation, sample standard deviation?
Yes.
This is now yes. The symbol is yes. Earlier it was mu and sigma. But now it is X bar and yes. Why are you calculating X bar and yes? You want to understand whether your process conditions are same or not. Whether your process is performing in the same manner. So far your company's population is very good, customers are happy. And now you are continuing producing. Whether the process will continue to satisfy your customer or not, you are trying to understand with the help of the average and standard deviation. If the sample average is close to the population average, you will be happy because your population average was close to customer target. All of you understand? So if the sample average is close to customer target, then your process is performing well. And similarly, the sample standard deviation. If the sample standard deviation is small, again it is good for your business. So the sample standard deviation is S, sample average is X bar. These are called statistics. All of you understand? These are called statistics. Earlier, for the population, what was the name? Parameter. But now for the sample, what is the name?
Statistics.
With the help of statistics, sometimes we try to understand the parameter. Am I right? For example, my company has produced only 100 pieces. But with the same process, next 6 months, my company is going to produce 10,000 units. Now 10,000 units will be population. But the 100 unit my company is producing today, that is going to be the sample, pilot production. Production part approval process. Some of you might be going through, isn't it? PPAP. So 100 units you produced and you calculate some statistics out of it, which is, sample average and sample standard deviation. What is your intention now? If my sample average is like this, sample standard deviation is like this, then my population parameter will be like this. If my population parameter is like this, I can pinpointedly understand what percentage of my population will be accepted by the customer. What percentage of population will be accepted? Will be accepted, and what percentage will be rejected. You, even before producing, you can take some judgment. Clear? So, if you use statistics to predict the parameters, the statistical study is called as inferential statistics. All of you, do you understand now?
Yes.
Or if you are using this in your business, current role, you are using some statistics and you are trying to take decision on the population. That is why your sample quality is very, very important. Am I right? If your sample quality is bad, then your decision on the population will also go wrong. Hope all of you know. So far, you are with me. Is it clear to all of you? Now I spoke about population. I spoke about sample. The characteristics of the population are known as population parameters. The characteristics of the sample are known as
Statistics.
statistics. Why I need statistics? Because I want to understand the parameter. Because when I understand the parameter, I now understand my population. Population means I have not produced. But even before producing, I want to understand. That is why you require statistics. If you try to understand the future, your statistics will be called inferential. If you try to understand the past, now your statistics is called descriptive. And inferential statistics, we all use very, very frequently, and descriptive also. Now, please note, I have written so many equations here, 68%, 95%, 99%, and so on. All these statements are based on the assumption that my data is normal. Am I correct?
Yes.
If
Yes.
data is not normal, my decision can easily go wrong. That is the reason why I have to be very, very careful during data collection. Because if I collect data the way I want, my data may not exhibit normality. But the rule of the nature is your business data should follow normal. That's the rule of the nature. Right? Now, if any process is run naturally, the data from the process will exhibit normality. If you try to influence the process, then your data will, will get, distracted. Isn't it? Instead of following a normal, everything might cluster on one side. Everything might try to go on to the right side, or everything might try to go on to the left side. All those things will happen. But a natural process will always exhibit normality, and you can expect normality normally. That is why it is called normal. It is called normal distribution. So now our assumption is based on the data is normal. Now, if my population is normal, or population is normally distributed, if my population is normally distributed, now chance for my sample to get normally distributed will be high or low?
High.
Will be high, because population is normal, so the sample will also be normal. Now what is required is, your sample size should be large. Am I right? Yes or no?
Yes.
Sample size should be, just when I take 2 sample and I cannot see bell or any kind, nothing I will see. I need a considerably large sample. Then only I will see my sample average close to population average. Otherwise, it will not happen. Another thing, my sampling technique should be sound, which means I should have an idea about the population, how my population is distributed. Same way, I will try to distribute my sample also. Say, for example, you are conducting a study in your city. Tell me, what is your city, one of you? Where do you live?
Navi Mumbai.
Navi Mumbai. Suppose you are doing a survey in Navi Mumbai. And Navi Mumbai, the traffic or the public, the what do you call, the residential areas varies with respect to the locality, isn't it? Many people live in the center, and in the outskirts, probably less people will live. Suppose you want to conduct a survey. Will you conduct survey only in the outskirts?
No.
You will cover the entire city. Same logic you should follow. When you are taking sample, you should cover the entire population. There is no point of taking sample only from a certain area, and you can't expect the sample statistics to to approach the population parameter. It will never happen. If you want your sample statistics to give you a clear idea about the population parameter, your sample should be spread across the population. You should have surveyed people living in the outskirts. You should have surveyed the people living in the heart of the city. You should also have included people living in other areas in your city in your survey. Am I correct? Then only your sample data will help you to understand the behavior of the population. So here the problem with first distribution, first set of data is population, and the corresponding distribution is called population distribution. Population distribution. The distribution of the population data is called population distribution. Here, the challenge here is too much of data. Challenge here is too much of data. And so it is difficult to collect all the data. So that is the reason why we always try to live using the sample distribution. But sample distribution, the challenge I have told you. What are the challenges in sample distribution? Number of samples. You require a large sample, isn't it? Then why do you require a large sample? Then only your sample statistics will approach population parameter. All of you, do you understand? I want to know what is the salary, average salary of a individual in Mumbai. I can't just go and ask Kiran, isn't it? Because Kiran is a kind of professional, his salary. But what is my question? What is the average salary of an individual in Navi Mumbai? Now I have to conduct a survey and to understand that number, isn't it? So now my sample distribution, survey size should be considerably high. Then only my findings will have, will be close to the reality. So sample distribution will be large. Another challenge in sampling the sample distribution is your sample should spread across the population. Most of the time, professionals like you and me, we fail to maintain this. We fail in any one of this. Either we collect insufficient data or we fail to spread the data across the population. All of you, do you understand where we are going wrong? And we get misled completely by the statistics. You know the reason why? Sample size is either not sufficient or we are not spreading the sample across the population. To avoid these two mistakes, you must always have a data collection plan. You must always have a data collection plan. And now, sampling technique, you cannot compromise. You have to have a proper technique. But sample size, I have a technique. Sample size. Now I am going to give you another scenario. Imagine on day 1, you took 20 samples. Day 1, you took 20 samples. And day 2, you take another 20 samples. Most of you in your company, you will be taking data in this manner only. Day 3, you took. But 20 is also a big number. Hope all of you agree with me. Nobody, generally takes 20 and all. They take only 4 or 5. Now, the 20 samples together should be called as subgroup number 1. All of you understand here what is subgroup number 1? What is subgroup number 1? How many data inside?
20.
20. And now subgroup 2. Subgroup 2. And then subgroup 3. Like this, I want you to collect data for several days. Let us say 25 days. Now, how many subgroups you have? Number of subgroups. How many is now?
25.
25. And inside every subgroup, how many data you have?
20.
20.
That is called the subgroup size. Now, every subgroup, you will have an average. Am I correct? All of you understand?
Yes.
Average of subgroup number 1. Then you have average of subgroup number 2. Likewise, you have average of subgroup number 25. So how many averages you now have? 25 averages. All of you so far with me?
Yes.
Yes.
I want you to visualize the distribution of subgroup averages. Do you understand what am I talking now? You need to visualize the distribution of subgroup averages. That means you are trying to control the average. Do you understand? That means you are trying to control the average. Your daily production, daily production is going on. Every shift there is a production going on. But you are going, and how many samples you are collecting? 20. And now you are trying to control the average of the 20. If you have good control over average of the 20, it is as good as controlling your daily production. Am I correct? Right?
Yes.
Now, distribution of the subgroup averages. I want to give it a name. The name is sampling distribution. The name is sampling distribution. Earlier, I taught you population. Then I taught you sample. Now I am teaching you sampling distribution. All of you know population distribution. Sorry. All of you know population distribution. You all know sample distribution. Now I am introducing sampling distribution. If you want to understand the population, better to work with the sampling distribution. Better to work with sampling distribution than sample distribution. Hereafter, when you are taking sample, always take multiple sample together. 5 at a time, 10 at a time. Don't just take one at a time. One at a time means it is sample. Multiple sample at a time means it is subgroup. Clear? And try to control the subgroup average, not the sample average. Try to control the subgroup average and not the sample average. Because if you can control the subgroup average, it is as good as controlling your population average. Why? Because the average of sampling distribution will converge to population average. You understand what I'm trying to say? If the average of the sampling, what is sampling distribution? Every point is an average. Am I right? Sampling distribution, every point is an average. You see here, 25 averages you visualized. Am I right? You visualized 25 averages, and the resulting distribution is called the sampling distribution. The another advantage is average of the subgroups. I mean, sampling distribution, chance for exhibiting normality will be very high. Chance for exhibiting normality will be very high. Please note, if population is normal, sampling distribution will certainly be normal. For any subgroup size, this is true. All of you are with me on the statement?
Yes.
Yes.
If population is normal, your sampling distribution will definitely be normal. Any subgroup size, you take 2, 3, 4, 5. So you can take decision confidently based on your knowledge on normal distribution. Otherwise, you will be in doubt. Because if your data is, if you plot a histogram, if it is not normal, you still apply the properties of normal distribution, and you will be deviating from the reality. But if you work with if you learn to work with sampling distribution, there is more chance for you to be correct in your decision making, because the sampling distribution, the tendency to exhibit normality is very, very high. Okay, another scenario. If population is non-normal, then also sampling distribution will be normal. Then also sampling distribution will be normal. Only requirement is subgroup size should be sufficiently large. That's all. What is sufficient? You have to know, you will come to know once you understand the process, once you start working with the data. Sometimes it is subgroup size of 5, sometimes it is subgroup size of 7, sometimes it is subgroup size of 10, but it won't be too high and all. All of you understand so far? I mean, this particular two statement is nothing but central limit theorem. What is this theorem?
Central limit here.
This is the reason why always you are collecting data you are collecting multiple samples when you are going for inspection. This is the reason why you always, try to monitor the average, not individual value. In X bar R chart, what are you monitoring? Are you monitoring in X bar chart? What are you monitoring? Are you monitoring individual value?
No, average.
Average value. Because the tendency for the average to exhibit normality is very high. And if it is not exhibiting, then you will immediately question your team why it is going out. And your question will have a real sense for the business. All of you, have you understood the last discussion today? Population distribution, you are very clear?
Yes.
Yes.
Sample distribution,
Yes.
then sampling distribution. One of you please tell me what's the difference between sample distribution and your sampling distribution. Please tell me what is the difference. Then we will close for the day. Already I dragged up to 9:20. What is the difference between sample distribution and sampling distribution?
For example, in this scenario, we had taken for 1 day is a sample distribution and combined 25 is a sampling distribution.
Very good. Okay, let me give another simple example. Right, in our current black belt batch, how many students are there?
Around 20.
70.
Around 20. Now, individual student marks I am collecting. Individual mark I am collecting. I am plotting a histogram. I'm plotting a histogram, right? And now what is this histogram called? Is it a sample distribution or population distribution or is it a sampling distribution?
This sample.
Population
This is,
Sample.
first of all, what is population? Our black belt. Our black belts are the population, isn't it?
Yes.
This year, our population is 26th batch you are. All right. The 26th batch for this year. So this year population is all 26 batch students data. That is the population. Maybe every batch assuming, 20, 25 people. And we have around approximately 500 black belts. 500 black belts exam mark, when I have it in an Excel sheet, the data is called population data.
Yes.
A population will have an average. And that population average reflects our performance, isn't it? How do we conduct the training? How do we students are learning from us? Population average. So based on the population average, we do marketing. Yeah, success rate, 100% passing rate, and you can score 95. All those things we are telling. Because, we have some information about the population we are telling. But you people, you only have access to only your batch. If the results are declared, you only come to know about the students in the batch. Now the result of each and every student in the batch, when I visualize, that is a sample distribution.
Yes.
Clear?
Yes, clear.
Very good. And now this sample average, will it be close to population average?
Yes.
Chances are there. Chances are there. Can be yes, can be no also. Suppose all of you perform badly. Your sample average can be well below population average. Suppose all of you perform extremely well. The sample average can be above population average. People may get misled looking at your performance. If somebody wanted to judge whether this place is good or not, instead of looking at the sample, they must try to have a better estimate. If the population information is available, nothing like it. But only people inside the organization, they will have the information. Not everybody will have access. So now another thing, another idea. Every batch, there will be 20 students and there will be batch average. Batch 1 average, batch 2 average, now 26th batch average. Now how many average I have? 26 average I have. Suppose when I release all the 26 averages, you can better judge on the population now. How? Calculate average of the 26 batches. Average of the averages. Average of the averages. This will be very close to your population average. This will be an estimate better than your sample average. Because over a year, we could have come across some better batch also, some worst batch also, and everything will be there in a year. Isn't it?
Yes.
Now I am calculating average of the averages, and definitely that will be a better estimate of the population. That is why it is always a great idea, good idea, and correct idea to work with the sampling distribution. But problem is, you have to stretch your study over a longer period. Am I right? You have to have the January batch also, December batch also. 1 year complete study, which is difficult in real time. You can overcome that also. You can overcome that also. For that, certain techniques are there. You only study one subgroup. You only study one subgroup, and that subgroup will have an average. That subgroup will have a standard deviation. And this subgroup average can help you to find out population average. Only one subgroup you studied. One subgroup average can help you to find out population average. Similarly, the standard deviation of the subgroup data can help you to find out the standard deviation of the population data. There are some formulas, some relationship between the two, using which even with the limited subgroup, you can get a better estimate of the population. Better estimate of the population means better understanding about the population. Population can be past, population can be future also. What will happen to our batches we will be conducting in the next year? That also I can try to understand. What happened to all the batches we already conducted in the year? That also I can try to understand, right? So I can, by working with the sampling distribution, I can predict well as I can understand well. How this is happening? With the help of the sampling distribution. So expecting the sampling distribution to exhibit normality, will be very close to reality. And the average of the central tendency of the sampling distribution will definitely approach central tendency of the population.